Hello one and all, and welcome to the Math Magic Show. Here we have this crazy looking function, and today, friends, we're going to answer these questions about it. These limits, is it even a function, and then these other limits, and all of it will be based on this graph. So take a look, friends. Okay, first one says the limit of f of x as x approaches negative infinity. So for this particular question, we got to focus on this part of the graph right here. Okay, you see this? So you see the graph is this part, and as you can see, it's tending towards the x-axis. In other words, the y-coordinates, which are represented by these little segments, you see they're getting smaller and smaller and smaller. That means that the value of this limit is equal to 0 because it's getting closer, the graph is getting closer and closer to the x-axis. That's like saying that the y-coordinates along the graph, are getting closer and closer to 0. That's why the value of this limit is 0. All right, friends, limit of f of x as x approaches negative 10 from the left side, according to this negative. So now we're approaching negative 10 from this direction. That's what it means to come towards negative 10 from the left side of it. And you see what the graph does is that the graph goes up towards here, correct? But then the graph up here doesn't continue towards positive infinity, it just holds at that hole. So now look over to here and you see that value is about 16, according to this ruler at least. I use this to measure this off. So that's a value of about 16 there. But now you see, as we approach towards negative 10 from the left side, the value is the y-coordinates, remember. This 0 here is a y-coordinate, right? When we are talking about limits, we're talking about what happens to the y-coordinates. So as x approaches negative 10 from the left, the y-coordinates approach positive 16. They don't ever have to reach positive 16, and they do not reach positive 16 because there's a hole there, okay? They just have to get very close right there. You see the y-coordinates here? They're approaching 16. They don't have to reach it. So that means that the value of the limit is 16. So this is done, this is done. Now at this point, for your own amusement and enrichment, of course, you should probably pause the video and try to answer the rest of these. So the limit of f of x as x approaches negative 10 from the right side, according to this little plus up here, an exponent. So this is different because now you're approaching negative 10 from the right side. That means from this direction. And now, as that occurs, look at what happens to the y-coordinates. The y-coordinates are going down this way, correct? The y-coordinates are going down this way. And in fact, when something is like a dashed line like this, it's meant to be a vertical asymptote. So that means there's always a gap between the graph and the vertical asymptote. In other words, the graph goes down forever. Notice this is like an arrow tip. So that means it goes down towards negative infinity right here. Therefore, this answer is negative infinity, friends. Excellent. Now, probably, to be honest, I should have begun by answering, is it a function? Let's do it now. So is this a function actually? Well, take a look at it. I'm going to do the vertical ruler test, the vertical line test. So when I sweep from left to right, you see the ruler interacts with the graph ever and only at one point everywhere all the way across. At that hole, well, keep in mind, so this hole is drawn always in these graphs enlarged, just so we can see it, but in reality, this hole here, remember, means that the graph doesn't even exist there. So for this piece of it, this passes the vertical line test all the way across. Now look at this other piece, okay? Right here, the vertical ruler test. So again, this interacts with the graph at ever and only at one point, all the way across. You see this point, all the way across until we get to here. Now here it gets a bit more interesting, right? You see the graph is defined here, but not defined here. That means that a vertical line, like the edge of the ruler, interacts with the graph at only this point here, but not up here. That means, again, this is okay, no problem. It's still passing the vertical line test. And then you go all the way across, ever and only at one point, right? Likewise to the hump and all the way to the left side, again, only one point. So definitely, is this a function? Well, yes, it would appear to be a function like this. So the answer is yes. Let's look at some additional limits now. So the limit as x approaches 5.5 again appears a little negative from the left side. So when that happens, you drop your chalk. So take a look here. When you approach negative 5, well, 5.5 rather from the left side, the values of the function, right, follow the graph. Right, the values of the function approach 4.5. They just happen to do it from below, from this direction. But nevertheless, that means that the value of this first limit is about 4.5, okay? The limit as x approaches 5.5 now from the right side, according to that little plus of f of x. So from the right side, it's going to look like the following. Well, when x is approaching 5.5 from the right side, you're coming from this direction towards 5.5. When that occurs, right, the y-coordinates, in this particular case, they happen to be constant, and they happen to be approaching the value 9.5 right there, you see? Actually, they're like it's equal to 9.5, equal to 9.5, all the way it's 9.5. So it's 9.5. Now, look at this. The limit as x approaches 5.5, and up here, notice there's no more minus or plus. It's just 5.5 of f of x. Well, since the limit from this direction is 4.5, the limit from this direction here is 9.5, there's a jump here, a break in the graph. That means that this baby here is D and E. It doesn't exist, in other words. Remember, for a limit to exist, these limits from the left and the right, as x approaches some value of some function, these limits have to have the same value. That is not the case here. And for the last part, the limit as x approaches 18 from the left side of f of x. All right, so that means x is approaching from the left side this way towards 18, and the values of the function, basically I was indicated by like little arrows along the graph to tell you that the y-coordinates are sliding down, and they're sliding down towards what value here? That's about 7.5 if you follow the edge of the ruler across. So here, friends, we end up with 7.5. And these are our beautiful answers. That is it for this one. So please do leave a like, please do subscribe, leave some comments down below and suggestions for future videos. I read through those, I find them useful. I will see you in another video.